All right, so a couple things to keep in mind on this. You're going to be asked some questions about the graph, but I'm just going to go ahead and sketch the graph here. All right, so this is a log. This is a log where the base is a value greater than 1. So it's the inverse of an exponential growth model. So your log, the log that's a base that has that basis looks like this. Okay, so that is the inverse of the growth model. And the vertical asymptote would be at x equals 0. All right, so that's your basic form. Well, this one, is there anything being added outside the function? No, so there's no vertical shift. Anything being added inside the function? No, so there's no horizontal shift. And so the only thing is this base of 6 changes the values of this, but the form of the graph is going to stay exactly as it is. Okay, the general form, this point, again, if you think about anytime you have anytime you're looking at the log base a, and it can be anything of 1. And let's think about what this would equal. Anytime you have log base anything of 1, now think about the exponential form of this. It's a to what power is equal to 1? So any base to the power of blank equals 1. What's the answer? So this property is true. A to the 0. So what that means is anytime your number inside here has a value of 1, the y is 0. So that allows you to find your x-intercept. And so if you do that, basically the x-intercept is whatever value of x would give you a 1 inside your log. So the answer is just 1, 0 for your x-intercept. The tendencies, it goes up and to the right. It goes down and approaches the asymptote. The asymptote doesn't shift horizontally, so it's just going to be at y equals 0. And the domain and range for this, the lowest y value or the lowest x value, it approaches 0 but doesn't equal it, so it's a parentheses at 0. It extends in x's all the way to infinity. And then the range is from negative infinity all the way to positive infinity. And so those would be the pieces of information I think. Is there